So hello guys, welcome back to another video. I hope you all are doing well. Today we will be solving the another problem of the blind 75 series. The problem is longest increasing subsequence. This is the problem guys. The problem statement is you are given an integer array nums, return the length of the longest strictly increasing subsequence. This is the standard problem of the dynamic programming guys, and the question is quite straightforward. You will be given an integer array nums as an input. You can see here in the parameters of a function, we are given an array as an input and we need to return the length of longest strictly increasing subsequence. Okay, so let's first understand what this subsequence is and what is longest increasing subsequence with the help of some examples. So what is a subsequence? A subsequence is contiguous or non-contiguous part of an array, but the only condition that need to be satisfied is the elements should appear in the same order as in the original array. Okay, so let's understand this with the help of an example. Suppose you are given an array which has elements as 1, 2, and 3. Okay, so if this is an array, the subsequences in this can be 1, 2. A single element can also be considered as a subsequence. So 1, 2, 3, 1, 2, 1, 3. So as long as the elements are appearing in the same order as they are in the original array, so whether they are contiguous or not, it will be considered as a subsequence. So what will not be considered as a subsequent? Let's see that this 2 1 will not be considered as a subsequence. Why? Because in the original array you can see that 1 appears before 2, but here I have written 2 before 1. So the order is not maintained same as the original array. So this will not be considered as a subsequence. So same goes for this 3 comma 2. In the original array 2 comes before 3, so I have written 3 before 2 here. So this will not be considered as a subsequence. So if the order is not maintained, it will not be considered as the subsequence. Otherwise, any part, if it is a contiguous or non-contiguous, if it follows the same order as in the original array, so it will be considered as a subsequence. Okay, now let's understand what is longest increasing subsequence. So a longest increasing subsequence is that subsequence in which all the elements appear in the increasing order, or we can say that a subsequence in which all the elements are in ascending order. Let's understand this also with the help of an example. So suppose you are given an array which has elements as this. So a increasing subsequence will be that subsequence in which each element is greater than its previous element. For example, in this subsequence, if I pick 2, 3, 7, 101 as a subsequence from this given array, so you can see that in this subsequence, this 3 is greater than 2, 7 is greater than 3, 101 is greater than 7. So each element is greater than the previous elements that appears before that element. So this will be considered as an increasing subsequence. So I need to find the maximum length of such increasing subsequence from given array. So in this array, the output will be 4 because the longest increasing subsequence that I can find in this given array will be of length 4. Okay. So this is what question demands from us. Now let's proceed towards the solution of this particular problem. Okay, so like as I need to find the subsequence, and that subsequence would be increasing and longest. Okay, so like whenever we want to find the subsequences, how we find to generate any of the subsequences, we use the pick and not pick method. Okay, so how will I generate any subsequence? Let's understand this with the help of an example. So suppose you are given this array as an input. So if you want any subsequence from this array, so you can form that subsequence by using pick and not pick method. Let's see how. Okay, so uh, for each and every index, if you want to form a subsequence, or if you want to generate a subsequence from this given array, for each and every index you will be having two choices. The first choice is either you will pick that element in your subsequence, or you will not pick that element in your subsequence. Okay, so suppose I am given this array and I want to form this subsequence. Okay, I want to form 2, 3, 7, 101 as a subsequence. So how will I form this using pick and not pick method? Let's understand this. So I will not pick this 10. I will not pick this 9. I will pick this 2. I will not pick this 5. I will pick this 3. I will pick this 7. I will pick 101. I will pick 101 and I will not pick 100. Sorry, I will not pick 18. Okay, so in this way I just discarded all other elements and picked 2, 3, 7, 101 to form this subsequence. Okay, so whenever we need to generate any subsequence from the given array, we will use the pick and not pick method. Okay, now you can see here, for each and every index, we are having two choices. Either I will pick that element in my subsequence, or I will not pick that element in my subsequence. Okay, so whenever we have such kind of scenario that we have multiple choices and we have multiple possibilities, and out of those possibilities I want to check all the possibilities and find out the best answer. So in all those cases we use recursion. So here we can clearly see that, for each and every index we are having two choices, and our final answer will be, generated by selecting some of these choices. So that is why we will use recursion over here. Okay, now let's see how our recursive solution will look like. So as I told you, for each and every index, we will be having two choices. The very first choice is either I will pick that element in my subsequence or I will not pick that element in my subsequence. So what I will do, I will start from the leftmost point, or you can say that I will start from the zeroth index. Okay. So as I told you, for zeroth index, what are the possibilities I will have? Either I will pick this element in my subsequence or I will not pick this element in my subsequence. Okay. So if I will not pick this element in my subsequence, what I will do, I will simply move to the next index and I will check the same conditions for the next element, that is 9 over here. So I will check same for 9, that whether I want to pick this particular element in my subsequence or I don't want to pick this particular element in my subsequence. Okay, but what if I want to pick this particular element in my subsequence? Okay, so as if I would be simply told to generate a subsequence, so I would say either I will pick or I will not pick. But we cannot just pick any element, without thinking about anything else. So we need to keep this condition in mind, that our subsequence that we are forming should be increasing, or the elements should be in the increasing order. So we need to check, our subsequence will, for making our subsequence as increasing, we need to check if the current element that we are picking, if it is greater than the last element that was picked in the subsequence or not. Okay, for example guys, if I am at this index 3, okay, suppose I have picked this 5. Okay, suppose I am at index 5, I picked this element 5 in my subsequence, and after picking 5 I move to the next index, that is 3. Okay, now for 3 again I have two choices. Either I will pick this particular 3 or I will not pick this particular 3 in my subsequence. Okay, so if I will not pick 3, I will simply move to the next index and check these conditions for the 7. But what if, if I have picked 5, my question to you is, can I pick 3 in the subsequence? The answer of this is no. Why no? Because if I will pick this particular 3, so my subsequence will not remain, increasing. So I cannot pick this particular 3 because this 3 is not greater than the last element that I have picked in my subsequence. Okay, so I can pick the element only if it is greater than the last element that was picked in the subsequence. So suppose like after 5 I didn't pick 3 and I moved to 7. So this time I can definitely pick the 7 in my subsequence. Why? Because this 7 is greater than the last element that I picked in my subsequence. So it is not violating the rule that the elements in the subsequent should be increasing. Okay, so I can pick 7 after 5, but I cannot pick 5 after 3. So I need to keep a track of the last element that I picked in my subsequence to decide whether I can pick current element in my subsequence or not. Okay, so my recursive function will look somewhat like this. So there will be two parameters. The first parameter will denote the index. As I told you, I will start from the leftmost index, and for each and every index, as I need to try out two possibilities, whether I will pick that element in my subsequence or not. Okay, so the another parameter will be previous index, that will keep a track of what is the last element that I have picked in my subsequence. Okay, so my recurrence relation will be, I will be having two parameters in my functions, uh, index and previous index. So this f of index comma previous index will represent the length of longest increasing subsequence that starts at index int if the last element that is picked in the subsequence is at index previous index. Okay, so it simply says that the longest increasing subsequence which will start from this particular index int if the last element that was picked in the subsequence is at this index. Okay, so this will simply return the length of that particular subsequence. Okay, now let's see how our pseudocode for recursion look like will look like. Okay, so as I told you, I will be having two parameters, index and previous index. Index to check the possibility for a particular index, and previous index will keep a track of the last index, that last element of the last index that I have picked in my subsequence. Okay, so uh, this very first statement that is written over here is a base case. So as I told you, I will start from the leftmost index or zeroth index. So as I will move ahead, okay, so when I will finally check out all the possibilities for all the indexes, and ultimately when I will be when all the elements will be over in the given array, so this will happen when I will move at the nth index. Okay, so if I have reached the nth index, it means I have tried out the possibilities for all the indices. So simply after that, I cannot increase the length anymore. So I will simply return 0 from here. Okay, so this is the base case. Now, as I told you, for each and every index, I will be having two choices. The very first choice is I will not pick that element in my subsequence. Okay, so if I am not picking that element in my subsequence, so there will be no change in the length. So I will simply increase 0 in the length. And what I will do, I will simply move to the index plus one. That is, I checked out the possibility for this index. Okay, and I decided that I will not include this particular element of this particular index in my answer. So what I will do, length will remain same because I didn't pick this, and I will move to the next index. Here you can see that I will move to the index plus one, and previous index will remain same because the last element that was picked is still same. I didn't pick this element. So previous the element, the index of the last element of a subsequence will remain same. Okay, now comes the second condition. So what if I want to pick that particular element in my subsequence? Okay, so guys, I can pick that as I told you, I can pick that element only if that element is greater than the last element which I picked in my subsequence. So this condition represents same. If array of index is greater than array of previous index, then only I can pick that element. But what if I am picking the element for the first time? Okay, so if I have not picked any element in the subsequence yet, so if I am picking the element for the first time in the subsequence, then I don't need to see the previous element. Okay, then I know I can first element I don't have to see for any other condition if I am picking the first element in my subsequence. So that if I don't have I will represent this condition by putting the value of previous index as -1. So previous index is equals to -1 simply represents that there is no element that I have picked in my subsequence yet. So if my previous index is equals to -1, that means I have not picked any element in my subsequence yet, or uh, array of index is greater than array of previous index. That means if my current element is greater than uh, the last element that was picked in the subsequence, if any of these two condition is satisfied, I will pick that element. And if I will pick that element, what will happen? Length will be increased by 1 because I am including one more element in my subsequence, and I will simply move to the next index. Now as I have picked this element in my subsequence, so this element will become the previous element or the last element of a subsequence. So I will replace this previous index by ind. Okay, and out of these two choices, whatever choices will give me the best answer, whatever choices will give me the maximum answer, I will simply return that. Okay, so this is the simple basic recursive solution for this particular problem. Let's write down the code for this particular approach. Okay, let's first write down the code for the recursive function. So it will return an integer value, and it will take two parameters, index and previous index. Okay, so what was the base case when I will reach at the nth index? So I will have to carry a vector. So if index is equals to nums dot size, I will simply return 0. So for each and every index, I had two possibilities. The very first possibility was I will not pick that element in my subsequence. So if I will not pick, what will happen? Length will be increased by 0. That is, length will remain as it is, and I will move to next index. and the previous index will remain as it is, and I will pass nums. Okay. The second possibility is I can pick the current element. So the value for pick initially will be 0, and when can I pick the current element in my subsequence? I can pick only if the previous index is -1, that is I am picking the element in the subsequence for the first time, or nums of index is greater than nums of previous index. So if I am picking the element in the subsequence for the first time, or the current element that I want to pick, if it is greater than the previous element that I picked in the subsequence, so if any of these two conditions get satisfied, then only I can pick the element in my subsequence. So if I will pick the element in my subsequence, what will happen? Length will be increased by 1, and I will move to next index. Now this current index will become the previous index, or it will become the last element of a subsequence. So previous index will be replaced by index, and I will pass nums as it is. So out of these two choices, whatever choice will give me the maximum answer, I will simply return that. Okay, so I will return maximum of pick and not pick. Okay, and here I will simply call this function. I will call this function. So I will start from the 0th index, and initially as I would have not picked any element in my subsequence, so previous index will be -1, and I will pass nums as it is, and I will simply return whatever this function will return. Let's try to run this plain recursive solution. Okay, it is working fine. It gets accepted. So what will be the time complexity? So as you can see over here, for each and every index, I am trying out two possibilities. Either I will pick that element in my subsequence, or I will not pick that element in my subsequence. So in the worst case, as I am trying out two possibilities for every subsequence, for every element, sorry, so it can go up to 2 raised to the power n. So the time complexity will be of exponential order. So definitely this solution will not be accepted here. So we have to optimize this. Whenever we want to optimize the recursive solution, we always think of memoization. Okay, so if you will see the parameters in the given recursive function, you will find that this index and previous index are the changing parameters, and this nums is not changing because it is passed as it is in all the recursive function calls. So this index and previous index are only changing parameters in my recursive function. The index can go from 0 to n minus 1, and previous index can go from -1 to n minus 1. So I can use a 2D array to store the value of those states for which the recursive function have already calculated the values. Okay, but in the 2D array I cannot have indexing as -1. So just for storing the value of states, what I will do, I will shift the previous index to right by one position. Okay, so if previous index is -1, I will simply consider that as 0. If previous index is 0, I will consider this as 1. So just for storing the states in a DP array, I am shifting the previous index to right by one position. Okay, let's write down the code for this memoization. So for the purpose of memoization, I will create a 2D array, rather a 2D vector of size n into n plus 1. Okay, so let me first store the size of this array in some variable. So I will create a 2D vector. Let's call this as dp. It will be initialized as -1. Okay, and I will simply pass this in my function. Same thing I will receive here uh, as a parameter. Okay, so the steps for memoization are very simple. I will simply check if the value for this state. So instead of previous index, I will use previous index plus 1. As I told you, we will be shifting the indexes to right by one position because of the negative indexes. because of the negative values that can occur in this previous index. So if this is not equal to -1, that means the value for this has been already calculated. I will simply return that value. Okay, I will pass this TP array in these recursive function calls. And before returning, what I will do, I will store the value for this particular state. So dp of index and previous index is equals to, let's run this. Oh sorry, it will be previous index plus 1. And guys, it is working fine. Let's submit this code. And yes, it got accepted. So in this way, by using the recursion and memoization, you can solve this problem. Now let's analyze the time complexity of this particular approach. So as these are the states, these are the changing states in my recursive function. So there will be total n into n new states for which I will calculate the value in my recursive function. So time complexity will be big O of n into n, and space complexity will be big O of n into n plus big O of n. This big O of n into n is for the 2D vector that I am using to store the value of states, and big O of n is auxiliary recursion stack space that will be used during the recursive function calls. Okay, so this is the time and space complexity for this particular approach. Now let's move towards the tabulation approach to solve this particular problem. So tabulation is a bottom-up approach to solve the dynamic programming problems. In tabulation approach or in bottom-up approach, what we do, we pre-compute the value of some of the sub-problems, which will be required to solve the bigger problem. So we will use the same approach here. So there are few simple steps which you need to follow to solve this problem using the tabulation or bottom-up approach. So initially what you need to do is you need to create a DP array of same size as that of array. So if you are given an array of size 8, you will create a DP array of 8 size, which will be initialized with 1. Now, what will DP of I represent? So this point is very important. DP of I will represent the longest increasing subsequence that ends at index I. Okay, let's understand this problem clearly. This statement clearly. DP of 0 will represent the longest increasing subsequence that ends at 0, or we can say that the longest increasing subsequence in which the last element will be the element which is present at index 0, that is 1. Okay, similarly, if I DP of 5 will represent longest increasing subsequence that ends at index 5, or I can say that longest increasing subsequence in which the last element will be that element which is present at index 5. So DP of 5 will represent the longest increasing subsequence in which the last element will be 7. I am not bothered about other elements. Other element could be anything, but last element will be 7 for sure. That is what DP of I will represent. Okay. So I will create a DP array that will be initialized with 1. So why 1? Because I know DP of I represents the longest increasing subsequence in which the last element is the element at index I. So I know for sure there will be one element in the subsequence. Now I need to fill this DP array using some of the computations. Let's see how will I fill this DP array. Okay, so I will start from the leftmost index, that is 0th index. Okay, what does DP of 0 represents? Longest increasing subsequence in which the last element is the element at 0th index. That is longest increasing subsequence in which the last element is 10. Okay, so last element is 10. If last element is 10, can I put some more elements before this 10? The answer is no. Why no? Because there are no more elements before this 0th index. So I cannot put more elements. I don't have any option of putting more elements. So value for this will remain 1, and I will move to the next index. Okay, so DP of 1 will represent longest increasing subsequence that ends at index 1, or I can say longest increasing subsequence in which the last element is that element which is present at index 1, that is the 9, that is 9. Okay, so if last element is 9, do I have option of putting some more elements? So I can put all the elements that are previous to this element 9 in this subsequence, but will I put this 10? The answer is no. Why will I not put? Because if I will put this 10, it will not remain the increasing subsequence. So I will, not put this 10 before 9, and I will simply move to the next index. So similarly, I will check for 2. So DP of 2 represents longest increasing subsequence in which the last element is 2. So if last element is 2, what are the possible options that I can put before this 2? The possible options are the elements at index 0 and 1. But will I put this 10 and 9 before 2? The answer is no. Why? Because these two elements are greater than 2. So I cannot put. So the value will remain 1 for this second index in the DP array. And I will move to the next index. Okay. So now I move to the third index. So DP of 3 will represent longest increasing subsequence in which the last element is 5. Okay, last element is 5. So can I put some more elements before this 5 to increase the length? Let's see. So what are the possible elements I have? So if I am at index 3, I can put the elements of 0, 1 and 2 before this before the element of this third index to increase its length. Okay, so will I put this 10? No. Will I put this 9? No. Why? The reason is very simple, because these two elements are greater than 5. So I will simply not put these elements before 5. But can I put this particular 2 before 5? Yes, I can put. And I will definitely put, because putting the elements before this 5, before putting this 2 before 5 will increase its length. So length up to 2 was 1. So if I will put this particular part before 5, so length will become 1 plus 1, that is 2. So longest increasing subsequence that ends at index 3 will be 2, will be of length 2. Okay, I have checked out all the possibilities. Now I will move to the next index. Okay, so if I am at the fourth index, the element is 3. So it means I need to find the longest increasing subsequence in which the last element is 3. Okay, I know last element is 3. So what are the other possible elements that I can put? Those, what are the other possible elements that I can put before this 3? So the elements are 10, 9, 2, 5. I will not put 10. I will not put 9. Why? Because these two are greater than 3. So I cannot put these two. Can I put 2? Yes, I can definitely put 2. So if I will put 2, length up to 2 was 1. So if I will put this before 3, length will be 1. 1 length up to 2 was 1 plus 1, that is 2. So it will be updated to 2. Okay, can I put 5 before 3? No, because 5 is greater than 3. I have calculated the value for 3. Now I will move to the next index. That is the fifth index. So the element at fifth index is 7. So what does uh, it means? The last element in the subsequence is 7. Now I need to find, can I put some more elements before this 7? So can I put 10? No. Can I put 9? No. Can I put 2 before 7? Yes, I can put. So if I will put, the length will be increased by 1, because length up to 2 was 1. And if I will put this before 7, so the new length will become 2. Okay, I have few more possibilities. Can I put 5? Yes, I can put. Okay, so length up to 5 was 2, and if I will put this particular part before 7, so the new length that will become the new length that will become is 3. Okay, similarly, I can put this 3 before 7. So length will be 2 plus 1, 3. So length is already 3. So I will not update value this time. Okay. Similarly, I have checked out the possibility for 7. Now I will check same possibilities for index 6. Okay. So the element at index 6 is 101. So last element of a subsequence is, if last element of a subsequence is 101, I need to find, can I put some more elements before this 101? So I will start from the 0th index. Can I put 10? Yes, I can put 10. So if I will put 10, length will be 1 plus 1, because length up to 10 is 1. So new length will be 2. Similarly, I will check for 9. If I will put 9 before this 101, so length will become 2. It is already 2. I can put 2, but length will remain 2. Can I put this 5, this part in which the last element is 5 before 101? Yes, I can put because 5 is less than 101. So new length will become 3 because length up to 5 was 2, and if I will put this before 101, new length will become 3. Okay, can I put this 4? The element that is fourth index, that is 3. Yes, I can put, but length will remain 3, so I will not consider this case. Can I put this 7 before 101? Yes, I can put. And longest increasing subsequence up to 7 was of length 3. So if I will put this particular part before 101, so the new length will become 3 plus 1, that is 4. Okay, and this is the maximum that I got till now. Okay, now I have checked out all the possibilities for this 101. Now next time, in the next iteration, I will check for 18. Okay, so DP of 7 represents the longest increasing subsequence in which the last element is 18. Now I need to find, can I put some more elements before this 18 to increase the length? I can put 10. So if I will put 10, length will be increased to 2. Okay. I can put 9. So length will remain 2. 1 plus 1, 2. So I will not update the value. I can put 2 because 2 is less than 18. But length will still remain 2. I can put 5 before 18. Length up to 5 was 2. So 2 plus 1 will be 3. So I will update this value to 3. Okay. Uh, can I put 3? Yes, I can put 3. But length will be 2 plus 1, 3. And it is already 3. Can I put 7? Yes, I can put 7. And length up to 7 was 3. So if I will put this particular part before 18, so new length will be 3 plus 1. That is 4. Okay. Similarly, I will check for next index. Can I put 101 before 18? No, because it is greater than 18. Okay, so uh, that the maximum length that I got is 4 for index 7. Okay, so in this way we will fill this TP table, and whatever maximum value that I will get in this TP table will simply be my answer. Okay, so in this way I will just fill this TP table and I will find out the maximum value in this TP table to get the answer of longest increasing subsequence for any given array. Okay, you can also verify that. You can see that, in the sixth index I got value 4, in the seventh index value 4. It means there is a longest increasing subsequence in which the last element is that element which is present at index 6. You can practically check to verify this. You can take the elements like 2, 5, 7, 101. If you take just this subsequence 2, 5, 7, and 101. Okay, you can see that this is an increasing subsequence, and this is the longest increasing subsequence in this given array, because you can check the order, all the elements are in the increasing order, and it also ends at index 6. So we can see that, this algorithm is working fine. We can practically verify this. Now let's write down the code for this particular approach. Then we will analyze the time and space complexity for this approach. Okay, let me store the size of this vector. So initially what I need to do is I need to create a DP array of size n, and it will be initialized to 1. Okay, I need to calculate the length of longest increasing subsequence. That will be the maximum value in my DP array. So let me initially initialize the value as 0. So what I will do, I will start from the 0th index and I will go till last index. And for each index, what I was doing, for each and every index, uh, I was checking out all the previous indexes before this. Okay, so I will start another loop which will start from 0. I will call this as previous, and it will go till index minus 1. Okay, so what will I check? I will check if nums of I is greater than nums of previous, and 1 plus dp of previous is greater than dp of I. So if these conditions get satisfied, I will simply update dp of I to 1 plus dp of previous, as I was doing in the algorithm. And when this loop will be over, this inner loop will be over, I would have calculated the value for this particular dp of I, and I need to calculate the max. I need to find out the maximum value in this dp array. So I will simply update lis as maximum of lis comma dp of I. Okay, finally when these iterations, these loops are over, I will be having my answer stored in this LIS variable. So I will simply return this. Let's run this, and guys, it's working fine. Let's submit this code. Okay, it got accepted. Now let's quickly analyze the time and space complexity. What will be the time complexity? So we are using two loops over here. Okay, so time complexity will depend upon these two loops. So this outer loop will run for n times. Okay, 0 to n minus 1, that is n times. It will run for n times for sure. So this previous loop, this inner loop, in which we have previous as a variable, like it will run variable number of times. For the like for first index it will run one number of time, then two, then three, but we can say that in the worst case it will run n number of times. Okay, so time complexity for this particular approach will be n into n. Okay, or we can say big O of n square. As you can see, I have written over here time complexity is big O of n into n because of these two nested loops that I am using in my approach. Okay, what will be the space complexity? The extra space that we are using is this vector that is named as dp. So this is the only extra space that I am using. So space complexity will be big O of n. Okay, so in this way, using the tabulation approach, you can solve this particular problem. So the code of all the approaches will be given in the description. You can check out the GitHub repository link that will be provided in the description. So this is all for today's video. We will meet in the next video. Bye bye.